Hey everyone, welcome back. Today we're going to look at converting degrees to radians and then radians to degrees. So here's our lovely unit circle that you should try to memorize as fast as possible, just make your life easier. But prior to doing that, probably first maybe think of the helpful factors. We don't usually count up to 180 or 360 by 30s, right? And we don't usually do it by 45s either. But because we'll be using multiples of these numbers so much, it would be really useful to get comfortable by counting to 360 by 30, by 45, by 60. It'll just make your life a lot easier. So let's take a look at some of these basic questions that you started to see. And again, eventually you're going to know exactly what 300 degrees is if you practice enough in terms of what it is in radians. But in the beginning, we usually tell you to multiply, put it as a ratio, and multiply by pi over 180. And that's our factor that when we multiply it, it'll take our degrees and it'll turn it into our radian measurement instead. So this is why I was talking about factors. It's good to know what's the greatest factor that goes into 180 and 360. Well, if I've gotten comfortable with the multiples of 60 that I mentioned before, I know that 60 goes into 180 3 times. Right? And 60 goes into 300 5 times. And again, you could, ignore the 0 and say 18 and 30, right? 6 goes into 18 3 times, and 6 goes into 35 times. That might be a little easier. But anyways, so let's multiply across 5 pi in my numerator and 3 in my denominator, right? So 300 degrees is equal to 5 pi over 3 radians. And then I have 15 degrees here, and I'm going to do that same process each time, right? I'm going to multiply by that factor of pi over 180. And here, I guess you could multiply them by 15 all the way up to 360 is good. But this one I could see giving you a little more difficult, especially at first. So we're going to use 15. It does go into 180, but maybe you have to do a little thinking. Maybe it's easier to think about, well, we could probably figure out kind of quickly how many times 15 goes into 90, which is half of 180, right? So 15 and 15 is 30. Another 30 would be 4 15s. Another 30 would be 9. So if 15 goes into, 6. If 15 goes into 90 6 times, well, it must be twice for 180. And again, I'm not sure what if your teacher allows you to use a little calculator, you could have come up with 15 going into 180 12 times. Right, and 15 goes into 15 once. And if we multiply across, right, we get pi times 1, which is pi, and we get 12 in our denominator. So 15 degrees is pi over 2 radians. Negatives, we're going to do these questions exactly the same. Later in a future video when we talk about coterminal angles, we'll get more into the negatives. But for now, if the question just says convert degrees to radians, we're just going to keep doing our process here. Put that over 1 to make a nice ratio to line up with pi over 180. And then 45 goes into 180, right? 45 goes into 180 once, and keep that negative so we don't lose it somewhere. And then 45 goes into 180 4 times, and if I multiply across, I get negative pi over 4. Moving along to 315 degrees, well, same thing here, 315 over 1. And I'm going to multiply by our factor of pi over 180, turn into radians. Well, let's see, what's the biggest number that goes into both of these? If we've practiced with those factors, I know that 45 goes into 180 4 times, and 45 goes into 315. Well, that would be, 7 times. See, I need to practice sometimes too. So 7 pi over 4 is my answer for 315 degrees. All right, moving along, 225. This is also another factor of 45. And I can once you do enough of these, you start seeing the patterns, right? If I add another 45 degrees, I'd be at 270. If I had one more 45 degrees, well, I'm at 315. So I can kind of guess what the answer is here already. But let's use in the beginning, it's nice to have a process before we really have a good grip on things. So let's do our same thing here. Well, 45 goes into 180 4 times. And then this is where that comes in before. Well, if I know 45 degrees goes into 180 4 times, well, what's one more, right? If I had 45 to 180, what do I get? I get that 225, right? So that's 5. And so I have 5 pi over 4. is the radian equivalent of 225. 360, this is one you should probably know quite quickly. 360 degrees, right? An entire rotation around our unit circle there, right? Or, you might think about it in real life, like if you're snowboarding or skiing, doing a complete turn. 360, again, in the beginning, if you're not comfortable yet, we'll use this common factor each time, right? 180 goes into 180 once, and 180 goes into 360 twice. And so I get 2 pi, and you might say over 1, but it's just 2 pi radians, right? A full rotation around our circle there is 2 pi radians. And let's do 3 last ones to make sure we have it, and then we'll move the opposite direction. So negative 120 degrees, and I'm going to multiply by that factor, pi over 180. Let's see. What goes into 120 and 160? 180. That would be 60 degrees is the largest factor. And let's say maybe I made a mistake. Let's say I didn't know that 60 was the largest factor that goes into both. Well, you don't make a mistake if you just say maybe you only thought of 30 degrees. Well, how many times does 30 degrees go into 180? Well, if it was 60, it would have been 3, but say, again, we didn't know. So if we're using 30, we can say it's 6. Right, and again, you can say 18 and 12, right? 3 goes into 18 6 times. And again, 3 goes into 12. How many times? Well, 4, right? Or into 30 goes into 120. And if I multiply across, I get 4 pi over 6. But always, I'm sure, don't say this is your final answer. That's why I'm not circling it, right? Always simplify. And I'm sure your math teacher has told you you always need to simplify. Maybe you'll get some points off if you don't, right? So this is 2 pi over 3. So again, it's okay not to be super comfortable with these factors in the beginning and choose the largest one, right? Just make sure your answer is always simplified. Moving along, 90 degrees. This is one of those questions that'll become really quick eventually after you practice a little. So 90 goes into 90 once, and 90 goes into 180 twice. And if I multiply across, I get pi over 2. Pi over 2 radians, 90 degrees. And lastly, 75 degrees. Let's see, we multiply by pi over 180. And again, this is one of those like slightly trickier ones where it's not 30 multiples of 30 degrees or 60 or something like that. It's 15. So if I take 15 degrees and 15 plus 15 is 30, plus another one's 45, plus another one's 60, one more, I'm at 5, right? 15 goes into 75 5 times. And from earlier, we came up with a number that 15 goes into 180 12 times. And if I multiply across, I get 5 pi over 12, right? And maybe if you're doing all this mental math, do you really know that 15 goes into 180 12 times? Well, you can always multiply it out, right? I'm going to quickly do this. 2 times 5, right, is 10. 2 times 1 is 2, plus 1 is 3. 1 times 5 is 5. 1 times 1 is 1. Add these up, 180. All right, nice. We did it, just to double check. All right, let's go backwards now. Let's convert from radians to degrees. Pi over 4, again, once you've done these enough, you're going to know exactly what pi over 4 is, right? It's on our unit circle here, and we can look up and say, oh, I know exactly. Oh, actually, I didn't put it on this unit circle. I only have multiples of 30. But, good, so we can't even cheat with pi over 4 over here. Regardless, let's do our work. We have pi over 4, and instead of multiplying by pi over 180, well, we're going the opposite way, so we're going to do the reverse. We're going to do 180 over pi. And one way, sometimes students say, well, how do I know which one it is, 180 over pi or pi over 180? Well, if we have radians are always going to have a pi somewhere in them, right? Or at least in these questions they do. Right? We want to get rid of that. Well, the only way to get rid of that is being able to cancel a pi from the numerator, right? And a pi from the denominator. So that's a nice quick check. Usually, when we're converting from radians to degrees, we need to get rid of that pi. So that's always going to cancel. And then if I'm looking at multiples of 4, well, 4 goes into 4 once. And what's 180 divided by 4? Well, earlier we looked at that and we saw that that goes 45 times, right? 45 degrees. And that's one of those fast facts that 45 degrees is pi over 4, and you're always going to, or very quickly, you will have that memorized. Same thing over here. Let's start off with negative pi over 2, and that's a big common one we see a lot, pi over 2. But it's just the beginning, so let's take our time and multiply by 180 over pi. Those should cancel, right, every single time. I'm going to put my negative here already so I don't forget about it. All right, 2 goes into 2 once, and what's 180 divided by 2? Well, that's 90. Right, so I have negative 90 degrees. And again, if you wrote over 1 in the beginning, that's fine. Just rewrite it. All right, now we have 2 pi over 3. Same process here. I want to convert it to degrees, so I'm going to do 180, and I didn't need that degree there, but that's okay. 180 over pi. Our pi's cancel nicely. I'm going to have 3. Let's see, 3 goes into 3 once, and how many times does 3 go into 180? Well, 180 divided by 3 is one of those common multiples of 60. 2 times 60 is 120 degrees. Moving along, negative pi. Well, negative pi, and you might already know this one, right? Pi is half the way around, because if we said 2 pi radians, right, was an entire circle before, well, 1 pi, or just pi itself, right, we don't need the 1 coefficient in front of there, is halfway. So you could probably guess right now what it is, but again, this is just the beginning, so let's take our time. Well, let's cancel that. Pi goes into pi once, right? Same thing down here. And what are we left with? Just 180. And don't forget the negative, right? Negative 180 degrees. And if you've played any of those Tony Hawk skateboarding games, a lot of times you get points for doing half a turn, right? That's 180. Another way, if you're a gamer, helpful way to memorize things in the beginning. All right, 4 pi over 3 times 180 over pi. Cancel my pi's. And then, just like before, we had 3 going into 180 60 times. So 4 times 60, right? 4 times 6 is 24. Add a 0, 240 degrees, right? Nothing in your denominator aside from 1. Moving along, 7 pi over 6 is 180 over pi. Well, what do? Cancel our pi's. And let's see, 6 and 180 now. Well, we know 6 goes into 6 once. And how many times does 6 go into 180? Again, maybe ignore the 0. Well, we know 6 goes into 18 3 times, right? So if we keep our 0 there, it's 30. And so we have 7 times 30, or 7 times 3, 21. Bring along the 0, 210 degrees, right? And nothing in your denominator except for 1. That looks pretty weird, right? Doesn't look simplified, so 200 equals 210 degrees. And our last 3, negative pi over 6. And let's multiply by 180 over pi. Well, we cancel those like always, right? There's a little 1 left there. And 6 goes into, 6 goes into 6 once. And 6 goes into 180 like we just said before, 30 times. So we get negative 30 over 1. And I wrote that again. Negative 30 degrees. And don't forget your degree symbol, right? Did I do them in the last ones? Yes. So I'm not sure how picky your math teacher is, but who knows? Why lose points if it's something that's easy to write? All right, 3 pi over 2 times our same factor here. Let's cancel our pi's. 2 goes into 2 once. 2 goes into 180, or the other way to think about it, right? 180 divided by 2, I get 90. Well, 3 times 9 is 27, so I bring along the 0, 270 degrees. And last but not least, 5 pi over 4. And we're going to multiply by our handy-dandy friend, 180 over pi. Cancel. 4 goes into 4 once. 4 goes into 180. How many times? Well, how many times does 4 go? Oh, it doesn't go evenly, so let's do 2 instead. 2 goes into 4 twice. 2 goes into 180 90 times. Oh, and I'm being a dummy, but that's okay. That's why. Take your time. We could multiply by 5 times 90, but if you had a little more clarity of mind, you would see that you can continue to divide. 2 goes into 2 once, right? And 2 goes into 90 45 times, right? So 5 times 45 is 225 degrees. All right. And also one thing to keep in mind is there are more common measurements here, and if I added them in, I'd have 45 degrees, right in the middle of those, right? 45, also known as pi over 4. And if I went over here, right, so 45 degrees plus another 45 is 90, plus another 45 is 135 degrees, also known as 3 pi over 4. If I add those in, add another 45, I'm at 180. Add another 45, I'm at 225. Or how many fourths of that? If this was 3 pi over 4, this is 4 over 4, that's 5 over 4, right? 5 pi over 4. Let's go another 45, we're at 270. Another 45. That one was a little better at least. We're at 315. And if that was 5 pi, 6 pi, 7 pi all over 4. So I just wanted to complete that because I noticed my unit circle was missing our pi over 4s. All right, perfect. Hope this helps. And again, if you can't do these questions as fast as I do, well, pause it before you do it and then check. Then you can press play and check with my answer. Hope this helps. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples or if you want another topic to be covered.